Net is there. Net is there. It was public now. Stand there, sir. Let it show me.
Okay, good morning everyone. So in the last class we were discussing about the concept of the origin of Earth, how Earth has originated, that we have covered in the last class, and also we saw certain hypotheses and certain theories. So we discussed what is the difference between hypothesis and theory, what difference lies between hypothesis and theory.
Hypothesis is something we assume.
Yeah. And theory?
Theory is that we give some evidences for
Yeah.
that.
So theories, we have evidences. That's why Big Bang theory, it is called as a theory. Why? Because we have evidences. What evidences we have? We discussed last class, redshift and blue shift, as well as cosmic microwave background. So these are evidences. That's why it is called as a theory. And hypothesis, we discussed certain hypotheses in the last class, like is nebular hypothesis. Another hypothesis that we discussed was tidal. Another hypothesis we discussed was binary star hypothesis. And another we discussed was planetesimal hypothesis. So these are the other hypotheses that we have covered, but we discussed the most accepted currently is Big Bang theory. Clear? Now, we discussed in the last class these terms, singularity as well as differentiation. What is singularity? What is a singularity? We discussed universe was initially a point mass, single mass, point mass. All the things are concentrated at one point, and this point is referred as what? This point is referred as a singularity. And we discussed these questions also. What questions has been asked in UPSC in 2017 paper regarding singularity, that also we have covered. Now second part we discussed was differentiation. What was differentiation? What was differentiation? So we discussed whenever any object is rotating, what will happen? What will happen? Two forces will act. What are the two forces? Centripetal and centrifugal. So one force will act towards the center, centripetal force. Another will act outward, which is called as a centrifugal force. So because of this centripetal and centrifugal force, the heavier element will what? Heavier elements will come towards center, while the lighter element will be ejected outward. So because of this force, the lighter element are ejected outward, while the heavier element are coming towards the center, and this is how differentiation started. So differences between heavier element and lighter element. Lighter element. Now the third process is called as accretion. Accretion. What is accretion? Term accretion means. Now when accretion means layer by layer deposition. So you are growing the material by layer deposition. This is called as what? This is called as a accretion process. And when this becomes a united part, when this becomes a united part, it is called as what? It is called as a cohesion. Cohesion means united unit. Cohesion means united unit. So this part is called as a cohesion. So accretion means what? Accretion means that layer by layer that you are depositing things over here. Like we discussed heavier element. Heavier element are coming towards the center. So heavier element will get deposited together, and this process is referred as what? This referred as accretion, while the lighter elements are something that are ejected outward. So lighter elements are deposited outward. These are deposited outward. So you see differentiation is happening between heavier and lighter, and also accretion process is happening. Deposition is something that is happening in this layer and the other layer. Clear? Any doubt regarding this one? So these are the terms. Whenever the Big Bang theory comes in the examination, you have to write these keywords: similarity, differentiation, cohesion, as well as accretion. Clear? Any doubt regarding this part? Now, how this Big Bang process start? So we discussed it start from a point mass from where explosion has occurred. Explosion has occurred. So it is started from a point mass from where the explosion has occurred. Clear? Now imagine if material are close together. If material are close together, what will happen? If material are close together, what will happen? Reaction. Any other thing?
Force increase.
Assume this is the class. Currently, you are sitting over here. If I bring 10 more people in this class, then what will happen?
Mass will increase.
You will see mass increase. If more people comes, let's say 100 people come, 1000 people come, 10,000 people come, sit in this room, what will happen? You will see the heat will grow up. More people means what? More density, more heat. Heat will nothing but grow up. Clear? Any doubt regarding this one? So when it was a point mass, what will happen? It has infinite density, it has infinite mass, infinite temperature. All these were there in the universe. Universe has infinite density, infinite mass, infinite temperature. This is something that was present at the time when universe was a singular point. Singularity was something that was present. Clear? So if more people are there, compactness are there, then what will happen? You will see more heat, more temperature. Clear? So that's why molecules, when they are close to each other, what will happen? Will have more heat. When they are away, then what will happen? Less heat is something that is going to be there. Clear? Any doubt regarding this particular part? So what you find is this particular infinite density, infinite mass, infinite temperature, singularity has exploded. Now when it exploded, what is happening? Now universe is expanding. So when it is explosion is happening, what will happen? The universe will expand. Now this expansion and explosion, led to creation of what we call as electrons and quark. This led to creation of what we call as electrons and quark. So this expansion and explosion led to creation of what we call as electron and quark. What is electron and what is quark? Any idea you have? Electron you have.
Negative charge.
Yeah, you have studied. Quark. Anyone is knowing about quark? Anyone having any idea regarding quark? The bit of background. Let's say there was an atomic theory in chemistry. You have studied about something called atomic theory. there was a first person who was Dalton. Dalton's atomic theory says what? That atoms are indivisible. Atoms cannot be further divided. So atoms are indivisible. That is what Dalton's atomic theories were saying, which comes in 19th century. But later on, with discovery of electron, proton, and neutron, we realize that atom itself is made up of what? Atom itself is made up of these elements: electron, proton, and neutron. It is not indivisible. It can be further divided into electron, proton, and neutron. So electron discovery was done by Thomson. J.J. Thomson has discovered electron. Like neutron was discovered by Chadwick. You see proton was discovered by Goldstein or Rutherford. So what you see is, okay, these are, okay, what? These are further subdivision of atoms, subatomic particles. That's why they are called as a subatomic. They are division of atoms, so that's why they are referred as a subatomic particles. Clear? But are these fundamental particles? Are these fundamental particles? What do you mean understand by the term fundamental particle? Fundamental means what? Base. Something that everything is made up of certain things. So whether these are fundamental particles or these are not fundamental particles. So later on, in 1940s to 1960s, you will see further discoveries. A lot of subatomic particles we have discovered. And later on we realized that there are, okay, what? There are two things. One is called as a fermions, another is called as a bosons. So fermions and bosons are the one which is leading to formation of all these, all these subatomic particles like proton and neutrons. Okay, they are made up of what? They are made up of nothing but, okay, fermions. Clear? And these fermions are of two types. One is called as a quark and another is called as a leptons. So this fermions is of two types. One is called as a quark and another is called as a leptons. Clear? Any doubt regarding this particular thing? So remember that electron, proton, neutron, when it was discovered, we thought that, okay, these are the most fundamental. These are not made up of any other thing. But later on, 40s to 60s, further studies revealed that, okay, these are not fundamental particles. They are also made up of various other particles. What were the particles named? We call them as a fermions, and fermions are of two types, quark as well as leptons. So these quark, this combination of quark creates what? Neutron and proton. So neutron and proton are made up of what? They are made up of these one, quark. Neutron and proton are made up of what? Quark. So when explosion happens, you see creation of whom? You see creation of electron, you see creation of nothing but, okay, quark. Clear? Any doubt regarding this particular thing? Now, as the universe is, okay, exploding and expanding, when expansion will happen, then what will happen? What will happen? We discussed, okay, explosion had happened from a single mass, explosion had happened. Now universe is trying to expand. Okay, it is moving apart from each other. When expansion is happening, what is happening? What is going to happen? What will happen to temperature? Decreases, okay, because we discussed when molecules are closer, temperature are higher. When molecules move away, what will happen? Temperature will decline. So when temperature will decline, what will happen? Substances are going to cool down. Okay, they are going to cool down. So you will see quark. Okay, quark are something that are cooling down. When the substance cools down, what will happen? When substance cools down, what will happen? They'll come closer to each other. Okay, when substance cools down, what will happen? They'll come closer to each other. For example, take a milk, boil it. What will happen to the milk volume? You'll see milk rises up. No, volume increases in your vessel. Okay, if you don't switch off, milk will what? Come out of the vessel. So what will happen is, okay, when you are giving a temperature to any substance, what will happen? It is expanding. So when you are, okay, cooling the substances, what will happen? It is going to nothing but, okay, contract. That is, okay, there. Clear? For example, take water, put it in freezer, what will happen? Convert into ice, compact form. It will convert into ice, it will become compact. So whenever substances are something that are, okay, whenever the substances are cooling down, they are going to what? They are going to come together. So when they are going to come together, these quarks will, as the universe is expanding, it is cooling down. Cooling causes quarks to come together. When quarks will come together, what will form? When quarks will come together, what will form? Neutrons and protons are going to be formed. Clear? So this is the next stage of nothing but, okay, the universe. Okay, this is the next stage. From the singular mass, the universe has exploded, and this explosion causes nothing but, okay, expansion. and creation of what we call as a electrons and quark. With further cooling, what will happen? The quarks are going to come together, as we discussed. Okay, which process? Which process will take place? Accretion. What is accretion? Just now we discussed. What is accretion? Layer by layer deposition. So that is okay. Quark are depositing itself. They are combining by layer, and as a result, they will turn into what? They will turn into nothing but okay, neutron and proton. Clear? So you will see now creation of what? You will see now creation of electron. You will also see now creation of neutron and proton. So you are also now seeing with quark combining, you are seeing now creation of what? Electron and proton. Clear? Any doubt regarding this one? Now, the still atom formation has not happened. Still atom formation has not happened in the universe. What is still there? We have a fundamental particle, quark is formed, electrons are formed, these are fundamental particles. From here, you see bigger particles are going to be formed, which are neutron as well as proton. Still atoms are not formed. Clear? Now with further expansion, with further cooling down, what will happen? With further expansion, further cooling down, what will happen? Now, these will come together. Electron, proton and neutron will come together, and when they will come together, what they are going to form? What they are going to form? They are going to form atoms. Okay, so that's why we say atoms is what? Atoms is okay, having proton and neutron at the center, while the electrons are something that are revolving around this nucleus. Okay, so atom is made up of what? Proton and neutron, while electron is something that are revolving around this nucleus. So when proton, neutron condense together and electron okay started revolving this particular thing, then it is called as what? Then it is called as a formation of atoms. Okay, so atoms are then formed. Which type of atom? Which type of atoms are formed? So you will see okay, the basic elements, basic atoms are going to be formed, like hydrogen, helium. Okay, those atoms are something that are formed. Here, now this is what okay built in that okay theory also, like we discussed Dalton's atomic theory, which initially came. It says atoms are what? Indivisible. We discussed discovery was done by Thomson. Thomson says that no, atoms are something that are made up of electrons also. That is okay there. Later on, you will see Rutherford. Rutherford came out with this theory and says that this model. Rutherford provided which model? Rutherford provided this model, that electron is revolving around the nucleus, while neutron and proton are within the nucleus. So nucleus is positively charged, while electrons are negatively charged. Okay, and why this electron is revolving around the nucleus? Why this electron is revolving around the nucleus? Lesser mass. Any other thing? Yes, okay. We discussed okay what? We discussed heavier element. Proton and neutrons are heavier because they are made up of what? They are made up of quark. Okay, they are heavier element. Just now we discussed will be where? At the center, and the lighter elements are going to be what? Okay, revolving around. That is okay there. So this is okay what you see. Formation is happening, and also there is a force of what? Force of attraction. Why force of attraction? Why force of attraction? You have studied in the physics like charges. What will happen to like charges? They are going to repel each other. Unlike charges, they are going to what? Attract each other. Okay, so what is here? Unlike charges, nucleus is which type of charge?
Commerce.
Okay, commerce. Okay, that's why I am getting basics. Okay, so like charges is what? Like charges is going to repel each other, while unlike charges are. Sometimes you see, okay, what? Sometimes you see two particles when you are bringing together, what will happen? They have some resistance. Repelling is there, like two magnets. Okay, you can see with the magnet, what will happen? Sometimes magnet attracts, sometimes magnet repels each other. That is okay there. Clear? So the magnet repulsion is because of magnetic field. Okay, now charge, why they are going to attract? Because of electric field. Okay, so what will happen is these two charges are going to attract. Like charges are okay, what? Like charges are going to repel, while unlike charges are going to attract. So nucleus is positively charged, while electrons are what? Negatively charged. Unlike charges. Okay, one is positive, one is negative. So this force of attraction is called as what? Electromagnetic force. This force is called as what? Electromagnetic force. So this force of attraction is referred as an electromagnetic force. Clear? Any doubt regarding this particular thing? So this is what Rutherford is talking about in his atomic model. Clear? Any doubt regarding this particular part? Now, next, okay, what? Next, okay, the coming is a Neil Bohr. Another person who has given this model, atomic model, which is a Neil Bohr. Now, what Neil Bohr is saying? What Neil Bohr is saying? Now, the problem with the Rutherford model was, if there is a force of attraction, then what will happen? If there is a force of attraction, what will happen? Ultimately, they should come together. Ultimately, electrons should come together and merge with who? Nucleus. Okay, this should come and merge with nothing but okay, nucleus. So, if this comes and merge with the nucleus, then what will happen? Then atom itself will not be existing, because atoms consist of what? We discussed nucleus. At the nucleus, you have proton and neutron, while electrons are revolving around nucleus. So if nucleus is not there and merge with nothing but okay, if electrons is not there and merge with the nucleus, then what will happen? Atom itself will not be there. Clear? So that is what Neil Bohr is okay talking about. This is a problem that we face with the Rutherford model. So Neil Bohr says that no, electrons will not merge. They will not merge. Like electrons will not revolve like this and come and merge with the nucleus. Rather, they move in a fixed energy shell. They move in a fixed energy shell along the nucleus. So this he referred as okay ALMN. These are the shells, okay, in which electrons are something that are revolving and they have a fixed energy. Okay, so that's why they will not come and merge. This model is referred as nothing but okay Neil Bohr model. Okay, so that's how evolution of atomic model you will study in chemistry. Clear? From Dalton's atomic model to Thomson atomic model to Rutherford model to Neil Bohr model. So initially we thought that atoms cannot be further divided, but later on we found that atoms is made up of what? Electron, proton and neutron. Further elements are there. Then Rutherford says that electron is revolving while neutron and proton is where? At the center. And finally Neil Bohr says that okay, they will not come and merge. Why they will not come and merge? Because they are revolving in a fixed energy shell. Clear? Any doubt regarding this one? So this is how evolution of atomic theory is something that is okay happening. Clear? So from the universe point mass you see expansion. Expansion led to creation of what? Electrons and quark. From here you see creation of what? Electron, neutron and proton. When quark combines, you saw the creation of this. And with further, okay, what? Further cooling, you see formation of what? Formation of atoms. Clear? Any doubt regarding this one? Now, so if you read periodic table, the first element of periodic table is what? Your hydrogen. The second is what? Helium. The third is what? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, then sodium, potassium, aluminum, and further okay things are there. Okay, so the first to form was what? The first to form were nothing but okay these two, hydrogen and helium. So when atoms are coming, when atoms are formed, you see electron, proton, neutrons are formed. Then you will see formation of who? Then you will see formation of hydrogen atom. Then you will see formation of which atom? Helium. Helium. Clear? So these are something that are formed. These are something that are formed. With further expansion of the universe, further cooling is happening. This further cooling led to what? This further cooling led to what? The hydrogen and helium. This further cooling led to hydrogen and helium coming together. And when hydrogen and helium coming together, then what will happen? You see a cloud of gases are going to be formed. Okay? With further cooling, hydrogen and helium are something that are coming together. And with hydrogen and helium coming together, what will happen? A cloud of gases are going to be formed. Now this cloud of gases we referred as what? Nebula. Last class we discussed nebular hypothesis. So this cloud of gases is referred as what? This cloud of gases is referred as a nebula. Clear? Any doubt regarding this particular part? So this is how the formation of nebula is something that is okay happening. Clear? Now from this nebula you will see what? when huge amount of what? When huge amount of this gases comes together, these nebula becomes okay what? This nebula turns into galaxies. So when huge amount of what? When huge amount of nebula or something that are coming together, then you'll see formation of what? Formation of galaxies. Clear? So this is how you see evolution has happened. Okay, this is how evolution had happened, and this is called as what? This is called as your Big Bang theory. So from explosion and from a single mass singularity, you'll see explosion had happened. At this singular point, you have infinite density, you have infinite mass, you have infinite temperature. When explosion had happened, you see creation of what? You see creation of electrons as well as quark. As we discussed, quarks are what? Fundamental particles. When quark combines, they forms what? They forms neutron and proton. This neutron and proton, when comes together with the electron, they forms what? They forms the atom. So formation of atom takes place. Then after the atom, what had happened? You saw the formation of gases, that hydrogen atom, helium atoms, these are formed. Will form formation of gases. With further expansion, gases will come together. When gases will come together, they will form a cloud of gases. This cloud of gases is referred as what? Nebula. When further nebula combines, they are going to form what? They are going to form a galaxies. Clear? Now, with further expansion of universe, what will happen? With further expansion of universe, what will happen? Now galaxies will further condense. Now the galaxies, okay, we are saying this is okay how nebula were formed, galaxies. Now this will become much more smaller. Condensation will happen, this will become much more smaller. Yeah? Now if you compact anything, what will happen? Okay, if you further compact anything, what will happen? Then you will see, okay, the material inside will be crushed, broken down, no? Okay, so if I try to nothing but, okay, what? If I try to compress this, what will happen? This material will nothing but, okay, breaks down. So when galaxies are something that are further compressed, material inside the galaxies are, okay, what? Further crushed, further broken down, and this led to formation of what? This led to formation of other, okay, elements, okay? This led to formation of other elements. Like you'll see lithium, beryllium, carbon, nitrogen, other elements are something that are being formed because of nothing but, okay, further crushing. And this also leads to formation of stars. Okay, this also led to formation of stars. Clear? Like in the last class we discussed about sun. We discussed what process is taking place in the sun, why sun is radiating energy. Why sun is radiating energy? We discussed fusion process. Why this fusion is taking place? What is fusion? We discussed two smaller nucleus combining to form what? Bigger nucleus. This is, okay, what fusion process is. So what will happen is you will see nothing but, okay, what? You will see nothing but, okay, when material are brought together. When material are brought together, what will happen? These nucleus will combine to form nothing but, okay, a bigger nucleus. Fusion process is taking place, and this fusion process give rise to the energy which suns is radiating. Clear? Any doubt regarding this one? So how the stars formation has happened inside the galaxies? How the star formation has happened inside the galaxies? As the galaxies further condensed, what will happen? What will happen? Material will come further together. This hydrogen will come further together. They will come further together. When they will fuse together, what will happen? They will form helium. Okay, and this process is, okay, will start what? This process is called as a fusion process. And this fusion process is responsible for what? For the sun's radiating energy. This fusion process is responsible for sun's radiating energy. And as we discussed, sun is what? Sun is a star. Last class we discussed what is a star. What is a star? What is the difference between star and a planet?
Which emits its own light.
Yeah, which emits its own light is called as a star, while the planet revolves around stars. Clear? So planet do not have its own energy, own light. So the sun, from where it is getting light? It is getting light through fusion process. And why this fusion process is happening? Why this fusion process is happening? As we discussed, as the universe is further cooling down, material will further come together. When material will further come together, what will happen? Fusion process will occur, and this has led to what? This has led to nothing but, okay, formation of energy. Clear? In the sun. Clear? Any doubt regarding this one? So this is how universe formation has happened. So what we have discussed, what are the chart, what was the timeline that you have to remember regarding Big Bang? From the singular point, singularity, What will happen after this? What will happen after this? Explosion. This explosion will lead to creation of whom? Electrons and quark. Yes, it will lead to electrons and quark. Further cooling will lead to quark combining together to form what? Protons and neutrons. Protons and neutrons. And this electron, when it combines with proton and neutron, what will happen? Atoms are going to form. This atom gives rise to what? The basic gases like hydrogen and helium. So this atom gave rise to the basic element like hydrogen and helium. From these gases, what will happen? With further expansion, further cooling, what will happen? What will happen? Yes, cloud of gases are going to be formed, and this cloud of gases is referred as what? Nebula. This is referred as a nebula. Clear? With nebula further condensing, huge amount of nebula condensing together forms a galaxies. Galaxies further cooling, further combining, what you will see? You will see creation of also stars in them. You will also see creation of fusion process starting. Fusion process is something that is starting. All these particular process will start, and you will also see formation of nothing but new stars in the galaxies. Clear? Any doubt regarding this one? So this is a timeline that you need to remember for what? This is the timeline that you need to remember for a Big Bang explosion. Clear? Any doubt regarding this particular part? So just make this timeline regarding Big Bang explosion. Now there is also a term which is referred as a big crunch. What is this particular big crunch? It is a speculation currently. It is currently a speculation. Clear? Speculation means what? What is the term speculation means? You are trying to project something, assume something which is still not proven. That is called as what? Speculation. Clear? So you are you are making certain postulate assumptions which is still not be proven. That is called as a speculation. Clear? Now the Big Bang theory was not able to explain why this explosion has occurred. From singularity, why you see this explosion is something that is occurring. Clear? So that part is not there. Okay, that part is not explained in a Big Bang theory. That why this particular explosion has occurred and why universe starts to nothing but accelerate or expand. We discussed evidences is there that universe is what? Universe is expanding. What evidences we have? Last class we discussed redshift phenomena and we discussed blue shift and also cosmic microwave background. So we have this proof that universe is something that is expanding. But why explosion has occurred? What was the reason behind that? So there is there is no yet conclusive proof regarding nothing but this particular point. So there's a speculation that currently the universe is in which phase? Universe is in expansion phase. Currently the universe is in which phase? It is in expansion phase. It is expanding right now because of explosion. But there will come a point when what will happen? Universe will reach to its limit. It has expanded to a limit, and after that what will happen? Universe will again starts to contract. Universe will again starts to contract because anything you are touching, it will stretch up to a point. Clear? So what will happen is there is a speculation among scientists that universe is currently expanding, And after a certain point of time, what will happen? It will reach its maximum limit, and after that, what will happen? It will starts to contract. Okay, again it will starts to contract. Till what point? Till it becomes again, okay, which point? A single point. Okay, this process is referred as a big crunch or death of universe. This is referred as a big crunch or death of universe. Clear? So after a certain point of time, universe will again starts to contract. When it will again starts to contract, what will happen? It will again forms a point mass from where it started. It started from a point mass. Again, it will convert itself into point mass, and this is referred as a big crunch or death of universe. However, still there is no conclusive proof regarding this. It is just a speculation right now, and that's why there is another theory which is called as a pulsating theory. Okay, there is another theory which is being right now being talked about, is called as a pulsating theory. Pulsating theory says that universe like pulse. Pulse is what, like this one. So you have like this pulse. So it says that universe undergoes two phases. One is expansion phase. Another is nothing but which phase? Contraction phase. So currently universe is in which phase? Expansion phase. Later on, it will come into what? Into contraction phase. This is what? This is explained through pulsating theory, that it talks about universe undergoing different phase of pulses. Clear? So last class we discussed when this explosion had happened, Big Bang explosion, around 14 billion years ago. Yes, roughly we take around this, and approximately this 13.8 billion, that is what being estimated by the scientists. So this explosion has happened around 14 billion years ago. And when our solar system is being formed? When our solar system is being formed? Because we discussed what? We discussed this timeline. First explosion had happened, then what will happen? Electron quarks formation, then what will happen? These coming together, then atom formation, then galaxies coming together, and what do you see? Stars are forming, that is there. So much later the sun formation is going to happen. Yeah? These phases has to be passed after explosion, and only what will happen? You'll see evolution of what? Evolution of nothing but different stars. Clear? So that's why you see our solar system is formed somewhere estimated to be around 4.6 billion years ago. Much later than Big Bang explosion. Much later than Big Bang explosion. Solar system is something that is expected to be formed. The age is being estimated right now is around 4.6 billion years ago. Fine. So as we discussed in our solar system last class, this point is called as what? Heliopause, after which sun's gravitational effect is what? Sun's gravitational effect is not being felt. This belt is referred as what? Kuiper belt. And we discussed this belt is referred as what? Asteroid belt. Yes. And this is where Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. So these are what? These are your these are your planets which are revolving around the sun. So what the nebular hypothesis says, remember? So we discussed nebula says what? That when this nebula is rotating, this cloud of gases and dust are rotating, what will happen? Yes, centrifugal and centripetal force will apply. All heavier element will come towards what? Center, and all lighter element will be ejected. So this lighter element has been ejected, and this has led to formation of planets. While the heavier element has come where? Towards the center of sun, and that's why we discussed in the last class that 99% mass of our 99.34% mass of our solar system comes from where? Comes from mass of sun only. Clear? All the major chunk of mass of our solar system is where it is located at this particular point, at the sun itself. Clear? Any doubt regarding this part? Now, remember the Earth is okay. What Earth is referred as the blue planet. Why it is referred as a blue planet? Because presence of water. Yes. Mars is referred as which type of planet? Red planet. Clear? Now, which is the hottest planet? No, Mercury is not the hottest planet. It is Venus. Yes. The hottest planet is Venus. Why? Why Venus is the hottest planet? Why Venus is the hottest planet? Though closer to the sun is what? Mercury. So Mercury should Mercury should be more hotter. But Mercury is not that much hotter. You see, Venus is something that is okay hotter. Yeah. For example, let's say you are closer to the room heater. What will happen? You are closer to the room heater. What will happen? More heat you are going to face. When you are away from the room heater, what will happen? Less heat. Okay, you are going to face. So one which is closer to the sun should have what? Should be more hotter. But one which is away from the sun should be what? Should be nothing but less hot. But why it is why we are saying Venus is more hottest? Why we have Venus more hottest planet rather than Mercury?
The gases which present in the will absorb heat from the sun.
The reason behind this is what? The reason behind this is, as we discussed in the last class, that the sun's radiation which is reaching to the earth is making what? Is making the earth hot. And once earth is hot, what is happening? Earth is releasing this radiation in the form of what? In the form of terrestrial radiation. So this is referred as what? This is referred as the terrestrial radiations. And this is called as what? This is called as the solar radiations. So whatever energy that is coming from the sun is called as a solar radiation. Generally, this solar radiation comes in the form of short wavelength. Generally, it comes in the form of which wavelength? Short wavelength. Remember last class we discussed the chart. What was the chart? So gamma rays, X-rays, ultraviolet. We discussed visible, infrared, micro and radio waves. So we discuss out of which have more wavelength? Which are more wavelength? Radio has most wavelength. Gamma has what? Least wavelength. And we discuss frequencies what? Radio have least frequency. Gamma has what? Maximum frequency. Clear? So this is what? This is how wavelength is increasing. Wavelength is increasing like this. And this is how frequency is something that is increasing. So sun's radiation is generally reaching in the form of what? Sun's radiation is generally reaching in the form of short wave. Okay, they are generally coming in the form of short wave. You know, you have studied about ozone layer. Ozone layer blocking which type of rays? UV rays. Okay, so ozone layer is blocking which type of solar radiation? UV radiation they are blocking. So sun's radiation is mainly coming either in the form of ultraviolet visible towards the earth. These are called as a solar radiation. Clear? Now atmosphere is transparent to what? Atmosphere is transparent to these radiation. It allows these radiation to come towards what? Comes towards the earth, and this is called as a solar radiation. Clear? Now what happens is what happens is further heating will happen. When further heating will happen, what you will see? You will see nothing but the earth will radiate now. This earth radiation is called as a terrestrial radiation. The earth radiation is mainly in the form of longer wavelength, like infrared. Earth is generally radiating things in the form of infrared radiation. So when earth is radiating, this is absorbed by whom? This is absorbed by the atmosphere. So when earth is radiating, this heat is being absorbed by whom? This heat is being absorbed by the atmosphere. Clear? Any doubt regarding this one? Why? Because we discussed atmosphere contains which type of gases? Which type of gases? Greenhouse gases. Atmosphere contains which type of gases? Greenhouse gases like carbon dioxide, like other gases. So you will see they contain which type of gases? They contain greenhouse gases. Clear? So these greenhouse gases absorb which type of radiation? They only absorb longer wavelength. They do not absorb which type of wavelength? Shorter wavelength. So that's why shorter wavelength comes towards whom? Comes towards the earth, while the longer wavelength which earth is radiating is absorbed by whom? Absorbed by atmosphere. So atmosphere is consisting Atmosphere is consisting of what? It is consisting of gases only. Okay, so we discussed which type of gases are present. Nitrogen is present, oxygen is present, in the carbon dioxide is present in the atmosphere. So this is okay. What this is atmosphere is containing lot amount of gases only. Clear? So mainly the heating is happening because of what? Of the atmosphere absorbing this radiation. Mainly heating is happening because of what? Atmosphere absorbing the radiation. If there is no atmosphere, then what will happen? If there is no atmosphere, what will happen?
The it will completely.
Yes, okay, whatever the heat that is being released now by the earth will escape into the will escape into the space. It will not be absorbed by whom? Absorbed by the atmosphere, because there is no atmosphere. Clear? So whatever the heat is being released, it is released in the space. Clear? So if any planet do not have any atmosphere, then what will happen? Then what will happen? Though it will get lot of solar radiation, it will also release what? All these heat. It will not absorb these heat. That is there. Clear? Any doubt regarding this one? So this is what happens with the mercury. Okay, this is what happens with the mercury. Since mercury is closer to the sun, there is no atmosphere in the mercury. There is no atmosphere in the mercury. Like Earth has an atmosphere, Earth is surrounded by the gases. There is no such atmosphere present in the case of mercury. Why Earth has an atmosphere? Why mercury do not have an atmosphere? It is because of gravitational pull of whom? Gravitational pull of sun. Sun is heavier, sun have more gravity. So whatever the gases are there will be attracted towards whom? Will be attracted towards the sun. Mercury is without any atmosphere. So when it is not without atmosphere, what will happen? It won't absorb much of heat. That is there. That's why Venus has an atmosphere. So whatever heat that is coming, Venus is absorbing that, and as a result, Venus is currently what? Hottest planet. So Mercury is not the hottest, though it is closer, but which is hottest? Venus is something that is hottest. Clear? Now next that you are finding here is the Venus is also considered as what we call as a morning and evening star. Morning and evening star with respect to Earth. Sometimes it can be seen morning and evening, so that's why it is also referred as a morning and evening star. And Venus is also referred as Earth's twin. It is also referred as Earth's twin. Why it is referred as a Earth's twin? Because its shape, size are similar to the Earth's. So like we discussed in the last class, Earth is in which shape? Geoid shape. So similar shape, similar size, you will also find Venus. That's why Venus is also referred as what? Referred as a Earth's twin. Clear? Any doubt regarding this particular part? Now, as we discussed, every object in the space, or every planet in the space undergoes what? Undergoes rotation and revolution. Last class we discussed there is no friction present. There is a gravitational pull, and because of which every things goes under rotation and revolution. What is a rotation and what is revolution? What do you understand by the term rotation? What is termed by revolution? And revolution? So let's assume, I'm nothing but standing like this. If I start moving on this part only, then what will happen? Rotation. It is rotation. If I start moving like this, it is a revolution. Clear? So rotation is on its axis. When any object is something that is moving, rotating on its axis, it is called as a rotation. When it starts to move like this, surrounds like this, then it is called as a revolution. So if you remember last class we talked about Kepler's law. What is Kepler's law? Remember last class Kepler's law we talked about. What was Kepler's law? That all planet revolves around sun and elliptical orbit. Remember Kepler's law talks about what? All planet revolves around the sun in an elliptical orbit, while the sun is While the sun is present at one of the focus of the ellipse. So we discuss all planet revolves around the sun in an elliptical orbit, while the sun is present at one of the focus. So that's why we discuss the planet comes near to the sun and planet moves away from the sun. So this part you have to keep in mind. Clear? Any doubt? So this nearest point is called as what? We discussed nearest point is called as what? What was the nearest point being called? It is called as a perigee. We discussed last class perigee and apogee. So nearest point is called as what? Perigee. Okay. The farthest point is referred as what? Apogee. Okay. Clear? So these are okay important things that you have to keep in mind. So that's why planet comes closer to the sun and planet moves also away from the sun because they are revolving in which type of orbit? They are revolving in an elliptical orbit. Clear? So rotation and revolution, two things are happening. Now when you are coming closer to the closer to the sun, what will happen? You are going to receive more heat. When you are moving away from the sun, what will happen? You are going to receive lesser heat. That is okay there. Clear? So as a result, what you see is you will see change of seasons. Change of seasons on Earth. So revolution is causing what? Change of seasons. Revolution will cause what? Change of seasons. Why it will cause change of season? Because you are coming either closer to the sun. When you are coming closer to the sun, what will happen? More heat will be received. More heat will be received means what? More summer climate. And when you are moving away, less heat, winter climate. So revolution is responsible for what? Change of seasons. Clear? The rotation is responsible for what? Day and night. Yes. Okay. So rotation is responsible for day and night. So the part which is facing the sun will have a day. The opposite part which is not facing the sun will have a night. When it will rotate, then what will happen? The other part will have a day and the first part will have a night. So rotation causes day and night. Clear? Now, out of these planets, which is the fastest rotating? Which planet is the fastest rotating planet? Mercury. Anyone else? It is Jupiter. So fastest rotation is of whom? Fastest rotation is of Jupiter. That you keep in mind. While fastest revolution is of whom? Mercury. Since Mercury is closest to whom? So Mercury have what? Fastest revolution. It completes it revolution in a quicker manner. While fastest rotation is what? Rotation is of nothing but Jupiter. For example, we discuss Earth, how much time it takes to rotate on its axis? 24 hours, like 23 hours, 56 minutes, roughly 24 hours we take it. So Earth takes this much time, while Jupiter, takes only 9 hours, 56 minutes to rotate on its axis. Jupiter is, having the fastest rotation. So Jupiter is having fastest rotation, Mercury is having what? Fastest rotation. Clear? So those parts also you keep in mind. Clear? Now, one more thing that you have to keep in mind is that currently we say solar system is consisting of sun and 8 planets. Now, what is a planet? As we discussed, planet is generally revolving around the stars. But what is the definition? What is the definition of this planet? Because earlier we discussed Pluto is also considered as what? It used to be considered as a planet, but now it is not considered as a planet, rather it is considered as a dwarf planet. It is considered as a dwarf planet. So earlier Pluto 9, we used to say solar system is consisting of sun and 9 planets. Now we are saying it is consisting of sun and 8 planets. Pluto is now not being considered as a planet. It is referred as a dwarf planet since 2006. So till 2006 we used to consider Pluto also as nothing but one of the planet. But now since 2006 we have revised the definition and now we are considering it as what? Dwarf planet. Clear? So what basically is a planet definition? The first definition is what?
It should have its own axis.
It should have its own axis to revolve. Any other thing?
It moves in an elliptical orbit.
It moves in an elliptical orbit. Any other thing? Any other definition? First thing, it should need to have sufficient gravitational pull. gravitational pull so as to acquire what? So as to acquire a spherical shape. It need to have sufficient gravitational pull so as to acquire spherical shape. All things need to pull together. It becomes a spherical shape. Clear? So that is okay. One of the points you have to keep in mind. Sufficient gravitational pull to acquire what? To acquire the spherical shape. Second thing, it should move around who? Move around the sun. It should move around who? Move around the sun. And the third thing, since it is moving around the sun in which orbit? Elliptical orbit. We discussed, okay, in this orbit there might be presence of whom? There might be presence of nothing but okay, other material also. What are the other material? Asteroids, meteors, comets, okay. You will have okay, rocky fragment, dust particles, okay. You will have many things that are present in this particular orbit. So what will happen? It should have okay, sufficient gravity to clear its orbit. It should have sufficient gravity to clear its orbit. All these materials should be what? Should be nothing but okay, cleared off. The path need to be cleared off. That's what okay. Another definition that you have to keep in mind. So it should clear its path. It should have sufficient gravity to clear its path. As we discussed last class, when or meteorites comes near that, okay, they burns into the atmosphere. This burning is referred as what? Meteors or shooting star. We discussed concept of shooting star in the last class. So what is happening? The earth is clearing its path. If at all any things are coming in the path of the earth is able to clear its path. It need to have sufficient gravity to clear its path. Clear? Any doubt regarding this one? So if any planet fulfill these criteria, then we call it as what? We call it as a planet. Now Pluto is meeting two of these conditions. The third condition is not being met. Okay, Pluto is not able to clear its path completely, and that's why Pluto is now referred as which type of planet? Dwarf planet. Clear? So Pluto is meeting two of these criteria, not meeting the third of criteria. It is not able to clear its path, and that's why it is referred as what? It is referred now as dwarf planet. Clear? Any doubt regarding this particular part? And who has given this definition? Who has given this definition? This definition is given by International Astronomical Union. So this definition is given by International Astronomical Union. Okay? This was created in 1940. This was created in 1940. So these important things that you have to keep in mind. So who has given the definition for planet? Definition for planet has been given by International Astronomical Union. This body was created when? In 1914. And why this body was created? Why this body was created? So that we can cooperate, we can coordinate with regard to study of our universe. We can coordinate with regard to study of our universe. That's why this body is being created, International Astronomical Union. Here, so as we discussed, Pluto is not able to meet which criteria? Yeah, it is not able to clear its path. That's why Pluto is now referred as which planet? Dwarf planet. This criteria is given by International Astronomical Union in 2006. So since 2006, okay, as we discussed, Pluto is now revised as a dwarf planet, not considered as the pure planet. Clear? Now there are two other terms you are finding: astronomy, cosmology, cosmic rays. What is the difference between these terms? Astronomy, cosmology, and cosmic rays. Have you heard this term? No. Or astronomy you have heard. What is astronomy?
Which deals with the space.
Which deals with the space. Okay. We are calling it astronomical union. So deals with the space. Anyone else? See, the universe, another name is cosmos. So universe is also referred as what? Cosmos. So study of universe is going to be called as what? Cosmology. So study of universe is called as a cosmology. So another name for universe is what? Cosmos, and study of universe is called as a cosmology. Clear? Now astronomy is basically study of celestial bodies. Study of celestial bodies. What are the celestial bodies? Yeah. Planet, stars, satellites. Okay, when you are trying to study all these particular asteroid, celestial bodies, their study is called as what? Their study is called as a astronomy. Clear? So these are the two things you keep in mind. One is cosmology, another is called as a astronomy. Yeah. Now the third is cosmic rays. As the name indicates, cosmic means what? Related to universe only. So whatever the rays that are originating from the universe are referred as what? Are referred as a cosmic rays. Whatever rays that are originating from the universe is called as a cosmic rays. Like the sun is there. Now the sun is consisting of these layers. So the sun is consisting of core, radiative zone, convective zone, photosphere, chromosphere and corona. These are the layers of sun. Clear? Like we discussed in the last class, Earth has an interior. Like that, different layers of the sun is also there. So what is different layers of the sun? Core, radiative zone, convective zone, photosphere, chromosphere, and the outer part is called as what? Corona. Clear? Remember coronavirus? Why coronavirus is named as a corona? Because it resembles the outer part of the sun. Virus was resembling the outer part of the sun. That's why it is referred as a coronavirus. Okay, clear? So the corona is something that is visible. The outer part of the sun, corona is visible only during eclipses. It is visible only during eclipses. When there is a total eclipse, solar eclipse, you will able to see the outer part of nothing but what? Outer part of this sun, and this is called as a corona. Clear? What is eclipse? What is eclipse? When moon comes in between what? Earth and sun. Okay, so sunlight is not able to reach to the earth, and that is called as what? That is called as a eclipse. So when moon comes, because moon is revolving around the earth, we discussed earth is revolving around whom? Sun. So there will be scenario when moon comes in between nothing but the sun and earth. This situation is called as what? This situation is called as an eclipse. So sun's radiation will not reach to the earth, and as a result, you will find this particular outer part of the sun is only visible, which is referred as what? Which is referred as a corona. Clear? Now, in the sun, we are taking what is taking place? Fusion process is taking place. Okay. In the sun, fusion process is something that is taking place, and from this sun also lot of high energy particles are also being emitted. This high energy particles which are emitted are referred as what? These are referred as a cosmic rays. So not only from the sun, from other stars also it is being released. So the high energy particles that are being released is referred as what? Is referred as a cosmic rays. These are referred as a cosmic rays. Clear? Clear? So clear the differences between astronomy, cosmology, cosmic rays, cosmos. If these terms comes, you can now differentiate between these terms.
Excuse me.
lot of radiations are coming from the sun. So as a result, outer part of the sun is not visible. Corona is not visible because of radiation coming out. So you'll see your radiation is reaching to your eyes. You will not be able to see the corona. Yeah. In the time of eclipses, no radiation is coming. When no radiation is coming, then what will happen? You are able to see nothing but the corona. Yeah. But sometimes you may have heard about doctors advising that you should not you should not directly see the eclipses from the naked eye. Why? Why?
Harmful radiation.
Yeah, harmful radiation. These are nothing but these are nothing but your cosmic rays. Okay, so harmful radiations are nothing but your cosmic rays which are coming. So that's why doctor advise not to see it with naked eyes, because these can damage your retina and eyes. Clear? Now can we move to next one? What is the correct one? Hmm? D. Neither one nor two. Anyone else?
Only one.
Only one is correct. Anyone else?
Two only.
Only two. Anyone else?
So both only.
Both one and two. All answers.
Big one choose just to get.
So Big Bang explosion has not predicted this situation.
Will undergo a big crunch situation, it will go.
It will undergo, but this is not told by which theory. Big Bang has not told this theory. We discussed, okay, this is currently the speculation. Scientists are predicting that, okay, there might be a big crunch situation that will occur, but this is not given in which theory? This is not given in a Big Bang explosion theory. Okay, Big Bang only says that currently the universe is what? Expanding in nature. We are thinking that, okay, we are predicting that after reaching its limit, what will happen? Starts to nothing but, okay, contract. So that's why first statement becomes what? Wrong statement. Okay. Second statement says the inflation. Inflation means what? Increase in size. Inflation means what? Increase in size. So inflation of universe has occurred after the explosion. Yes, after the explosion, universe has expanded at much rapid pace. At much rapid pace, leading to the formation of gases like hydrogen and helium. Yes. Okay. So you saw the first formation as what? You see quark. From the quark, what had happened? Proton, neutron, then from proton, neutron, you see gases forms, hydrogen, helium. So yes, okay, this expansion has only led to nothing but formation of gases like this. So that's why answer here will be what? 2 only. Okay, so like that questions can be asked in case of examinations. So such type of questions can be found related to these theories. Clear? So remember what theories are saying. Clear? Don't mix things together like Big Crunch is also explained by the Big Bang? No, it is not explained by the Big Bang. Clear? Any doubt anyone is having? You are
So
noting it
since
down?
it is not proved, they are not asking exams.
Which one?
The theories.
Which theory? Big Bang?
Yes, what are the theories? Since it is not yet proved.
No, nebular hypothesis and other is given in CRT. It can be asked in
So
examination.
this is only the thing which is not proved.
No, Big Crunch also they can ask it. Okay, they can ask what the term Big Crunch means. Okay, this is a speculation.
Yes.
Okay, this is a speculation. We are predicting that it may happen. Clear? So currently you have to also understand these particular terms. This may be asked in examination. It's not that it will not be asked in examination. This, see, any knowledge how you build. Any knowledge how you build. Like we discussed, okay, atom is indivisible. Dalton is saying what? Atom is indivisible. So he has given his theory that, okay, what? Atom is indivisible. Now, later on we are, okay, what? We are saying that no, you are wrong. Okay, Thomson is saying atom is consisting of what? Electron, proton. Okay, so what will happen? You are wrong. So first you give any theory, then, okay, what will happen? Criticism comes. Okay, new discovery comes, new invention comes. Okay, then what will happen? We say that previous is wrong, now this is, okay, correct. Clear? So this is how, okay, the things has happened. Like we discussed, okay, even with regard to Big Bang explosion, it has not come, okay, first, no. First what has come? Nebular hypothesis, okay, you see planetesimal. Criticism has happened of this theory. Then we have arrived at which theory? The Big Bang, okay. So like that, now, okay, we are thinking about Big Crunch. Now tomorrow it may be proved correctly, it may be proved wrong. Clear? That may happen because it is currently a speculation. Okay, so it may be proved correctly, also it may be proved wrong. But this is how we build on knowledge. Okay, we create something, then we discuss on those particular things, we try to prove it wrong, and then, okay, what will happen? This is how the knowledge is, okay, being built. Okay, so that is how science, okay, works. Okay.
In second statement, when you mentioned at a much rapid pace, you stated that Big Bang theory happened like 14 billion years ago, and then this was like 4.6 billion years after that. So when you use such term, will it be like?
Yeah, rapid. Our solar system is formed, okay, around 4.6 billion years ago. But there are many stars which are older than what? Which are older than the sun. Sun is currently in young phase. Okay, we say sun is currently in young phase. Like, okay, you'll see, like you'll study in science and tech this part, but just for your information, I'll just explain you. Like nebula forms this stage is there. This stage leads to formation of what? Formation of star. From here comes your protostar. Write it in different slides. There is a nebula. This nebula contains to form what we call as a protostar, and this protostar then changes into main sequence star. Main sequence star. This can be, okay, what? This is where the fusion process is starting. This is where fusion process is starting. The star starts to emit its own light. Clear? Now this main sequence star can be either bigger or this can be smaller. This main sequence star can be bigger or this main sequence star can be smaller in nature, depending upon what? Depending upon the nebula. How much nebula cloud of gases has come. Okay, if it is more, then what will happen? Bigger star. If it is less, then what will happen? Smaller star. So main sequence star is okay where bigger and smaller stars are coming together. Clear? Then these stars goes under what? These stars undergoes two phases. It is called as a red supergiant phase. Red supergiant phase. Then it is called as a red giant phase. So stars, when it runs out of hydrogen, because we discussed what happening in fusion process. Hydrogen is combining to form what? Helium. But when there is no hydrogen left, then what will happen? No helium is okay going to be formed. Clear? So when no helium is going to be formed, stars will enter into nothing but okay this phase, which is called as a red giant or red supergiant. So bigger star will undergo this phase, smaller star will undergo nothing but okay this phase. Clear? From here, it will change into what we call as a planetary nebula phase. Then undergo nova explosions to form what we call as white star or black star. Finally cools down and forms a black star. Yeah. Now here, after red supergiant phase, you can see a supernova explosion. You will see a supernova explosion, and you will see either formation of a neutron star or you will see a formation of a black hole. So this is how, okay, the formation happens, okay. So when explosion happens, what will happen? When nova explosion happens, supernova explosion happens, what will happen? Again, what will happen? Dust and gases are going to be released. These dust and gases will trigger what? Will trigger formation of what? Nebula. Nebula again will change into what? Proto star, then main sequence star, that is okay there. So this is how, when a star dies, a new star is born. Clear? When one star dies off, another star is something that is okay being born. Okay, so this process is something that is currently going on. Currently the sun is in which phase? Currently the sun is okay over here. Sun is okay, which type of star? Sun is a smaller star. Sun is not a bigger star. Sun is a smaller star, and currently the sun is in which phase? Currently the sun is in main sequence star phase. Clear? Any doubt regarding this particular part? So this important thing that you have to keep in mind. Now, what is a black hole basically? What this black hole is all about? Black hole is something which is not interacting with the light. It is something that is not interacting with the light. Anything which is not, anything which is appears black, white appears black. Anything appears black, white appears black. Like why you see a plant as a green color?
Because light falls on it and it reflects on the wall.
Yeah, the green color is reflected on your eye, and that's why you see things as a green color. Clear? So plant leaves and etc. are seen as a green color because the light falls on it. Out of this, all other lights are absorbed. Blue color is absorbed, red color is absorbed. Other lights are absorbed because visible. Remember visible rays we discussed with your. Remember violet, indigo, blue, green, yellow, orange, red. So what you see is when these light falls, what will happen? All other lights are absorbed. Only which one is reflected? Green is reflected. That's why you see something as a green color. Clear? When no light is reflected, then what will happen? Black color, because nothing is reaching to you. So that's why you will not be able to see. That's why it is going to be seen as what? Black color. So black color is going to be seen when all light are being absorbed by the material. Clear? When all light are being absorbed by the material, it will look like what? It will look like a black color. If all light are reflected, then nothing is absorbed by the material, then white color. Then white color you are going to see. Clear? Any doubt regarding this one? So black hole is appears black because it do not interact with the light. Clear? So how do you find that this substance is something that is existing? How do you find this substance is something that is existing? When it is not visible because it do not interact with the light, How do we find that it is okay, something that is okay present?
Because it has more gravity.
Yeah, the reason is gravity. Okay, so let's say this is a black hole. We are not able to see this particular black hole, but any substance which is coming near to this, okay, is what? Is absorbed, okay, because of the gravity. Anything that is coming near to this is okay, being absorbed. So we know that there exists something, okay, in this area, but it is not visible to us, okay. So it interacts with the gravity, but do not interact with the light. Clear? Any doubt regarding this one? So anything coming closer to this black hole will get sucked into black hole. Why it will get sucked into black hole? Why it gets sucked into black hole? Because of high gravitational pull of, okay, this particular substance. Clear? So that's why, okay, we know that black hole do exist, but okay, we are not able to see this particular black hole. Why we are not able to see this black hole?
It
Doesn't interact with the light. Clear? Now, there is something which is called as a wave, which is referred as a gravitational wave also. Just keep that in mind also. Since we are discussing black hole, just keep this in mind. Again, we will read more in detail regarding gravitational wave in science and tech classes. Now, what is a wave basically? How do we define the term wave? What is a wave?
Which consists crust
Trough,
and
crust and peak.
Crust and trough. Okay, is every wave have crust and trough? Is every wave have a crust and trough? There are certain waves which have compression and rarefaction also. Have studied? Okay, like okay, waves can travel either like this. This is okay how wave can travel, or they can also travel like this. Okay, so this is what? Compression and rarefaction, compression, rarefaction. So this is okay what? Okay, the two wave can travel. So not every wave can have crust and trough. Clear? So how do you define the okay wave? In simple term, let's say there is a water and you are throwing stone in a water, what will happen? Ponds are there, lakes are there, okay, you are throwing a stone in that, what will happen? Waves are generated. Waves are generated. Why this waves is generated? Why this wave is generated? Because you are disturbing what? Disturbing the medium. So wave is nothing but okay generated due to disturbance in a medium. Clear? Water was static. Okay, it was not okay moving in lakes and ponds. It was static. You have thrown a stone. Now you have disturbed the water. Now this water has led to what? Okay, the generation of waves. Okay, so whenever there is okay disturbance in a medium, what is going to be generated? Waves are going to be generated. Clear? So likewise, when there is a okay what? When there is a something, black holes is trying to okay what? Black holes is trying to absorb something, or black hole if something comes near to the black hole is absorbing, or two black holes which are coming together and then they are merging. Then what will happen? It will create a disturbance in the space. Okay, this disturbance will give rise to which type of wave? Gravitational wave. Okay, so this disturbance is going to give rise to which type of wave? Gravitational waves. So we are trying to study this waves also, gravitational waves also. Why we are trying to study this gravitational wave? Because this will give information again regarding formation of universe, how stars are being formed, how black holes are being formed. So we are trying to study this particular okay gravitational wave also. Fine. Anyone having any doubt? So this is all about what? This is all about how the expansion of universe, Big Bang theory, the big crunch situation, the term related to the universe, which is okay what? Which is astronomy, cosmic rays and other thing. Clear? Anyone having any doubt right now in this one? So now we'll move on to our next topic, which is interior of Earth. You want a break? Interior of Earth. Have a break and then.
It's good.
You're gonna get this type of question in the mains. Discuss the formation of universe as explained by Big Bang theory. Discuss the significance of this theory as well as criticism.
So how many marks are this question?
You can get around 10 marks. 10 mark question. So, like we discussed, significance is what? That it is able to explain the formation of a universe, like from single mass, how the proton has been formed, how the atoms has been formed, how galaxies has been formed, how you saw stars has been formed. All this formation has been explained by who? All this formation has been explained by the Big Bang theory. But there are certain problems also. What are the problems with the theories? Like we discussed, why explosion has occurred? It has not been able to explain why the explosion has occurred from singularity point. So that's where shortfall is there. How much expansion can happen? Okay, up to what limit? Whether big crunch is available, not available? Those things are not explained. There are certain criticism also on this particular theory. So you will get such type of question in the mains examination. But still, since we are new to the class, we are not taking up still answer writing part. Okay, just have 2, 3 classes, 5 classes, and then we will have a content. Then on that content, we will discuss the answer writing part. Fine. So interior of Earth, that you have to keep in mind. Now, so now we are coming to the concept of interior of Earth. The first is what are the sources to study the interior of Earth? So what are the sources you have to study? How you get information regarding interior of Earth? There are 2 sources. One is called as a direct sources, another is called as a indirect sources. Direct sources means it is going to give information directly. It is going to give information directly. That's why it is a direct sources. Indirect means by analyzing things, we can deduce certain information regarding interior of Earth. So that's why they are referred as what? They are referred as a indirect sources. So there are 2 sources. One is called as a direct sources, another is called as the indirect sources. Clear? Now, let's say this is the Earth's surface. This is the Earth's surface, and these are what? These are different layers of Earth. These are different layers of Earth. How do we get, okay, what lies over here? What lies over here? What lies over here? How do you get such information? The one information is mining. You dig it. So you are digging up, okay, and you are going down and seeing, okay, what is there in the interior of Earth. Clear? But how much maximum you can dig? That is okay the question. For example, the deepest, the mines that we have is referred as Anconig mines, and this mines lies in South Africa. It is a gold mines. It is a gold mine, lies in South Africa. This is the deepest mine that you are seeing, and this deepest mine is around 3.9 kilometers. So you are able to dig how much deep? 3.9 kilometer up to 4 kilometer. That is okay there. Clear? What is the radius of Earth? What is the radius of Earth? If you see radius of Earth, it is around 6300 kilometers. Clear? So very large amount of very large amount of things you are finding, but you are not able to dig that much. The deepest that you have is around 4 kilometers. Clear? So though mining can provide you certain information, but it can provide you certain information regarding the things that are closer to the Earth's surface, not what is there beneath the Earth's surface, much deeper in the Earth's surface. It doesn't give you much information. Similarly, the things also there with regard to drilling. Drilling also, you can dig, you can drill it, and you can go inside, but again drilling also have its own limitations. You can't drill much, that is okay there. Third is volcanic eruption. Now, this is Earth's surface. Now material from the interior of Earth can come out in the form of what? In the form of volcanic eruption onto the surface of Earth. And since these are bringing the material from interior of Earth, you can analyze this material and you can find out what lies beneath the Earth's surface. So volcanic eruption is another source that can provide you information. Since these are directly providing you information, then that's why it is called as what? It is called as a direct sources. But there are certain sources which are called as a what? Which are called as a indirect sources. There are certain sources which are referred as a indirect sources. One of the sources is what? Meteors. Clear? As we discussed, Earth is coming from where? Earth is coming from the Big Bang explosion. When meteors are also formed from what? Big Bang explosions. Clear? Meteoroids are formed from that only. We discussed what is meteoroids. It is the fragments from the fragments from asteroid, fragments from planets. Then it becomes what? It becomes something but meteoroids. Okay. So when these are coming onto the surface of Earth, you can study them, and you can find out that the Earth also looks similar like this. You can deduce this information by studying the meteors. You can deduce this information that Earth also might look like this, or Earth core also might look like this, or Earth crust also might look like this. So that information you can deduce, that is called as a meteors. Clear? Next is a wave. Wave is a seismic wave. Seismic wave means what? Earthquake wave. So seismic means earthquake wave. So whenever earthquake occurs, as we discussed, what is happening? Disturbance is occurring on the Earth's surface. When this disturbance will occur, we discuss what will happen. Waves will be generated. Clear? Now these waves can travel through different parts of the Earth. Let's say here earthquake is something that is generating. Now the waves are generated from here. These waves can travel in what? These waves can travel in different directions. Clear? These waves can travel in different directions. So when these waves are reaching to the surface, what will happen? They are passing through They are passing through crust region also, mantle region also, core region also. So what will happen? You are deriving this information regarding the Earth's interior from how these waves are something that are moving. Clear? Now the waves also moves depending upon, as we discussed, whether it is transverse wave or longitudinal wave. So just now we discussed transverse wave move in the form of what? Crest and trough. Longitudinal wave moves in the form of what? Compression and rarefaction. So they will move in the form of compression and rarefaction, compression and rarefaction. This is how they are going to move. Clear? So in which substances you will see transverse wave are going to move? In which substances transverse wave are going to move? In liquid. Anyone else? In which substances you generally see transverse wave are moving? Generally, you don't see transverse wave moving towards moving through the liquid and gas. They are more they are more solid. Longitudinal can move in all three, but transverse cannot move in the liquid and gas. They can only move in which type of one? Solid line. They can move only in which type of one? Solid one. Why? Because if they are moving like up and down, okay, transverse wave are moving like up and down. So if they are moving up means what? They are changing the shape of the object. Let's say this is the object. Now this part of the object is going up means what? You are changing the shape of the object. So the object need to have that much, okay, what? That much resistance, so that, okay, what will happen? It comes back to its original shape. Otherwise, okay, what will happen? It can deform its shape. Clear? So if it moves up, if it is not able to come back, then what will happen? The shape of the object changes, no? Clear? If anything is, okay, like this, let's say because of the wave it is moving up, if it is moving up, then what will happen? It is changing the shape of the object. If it is not able to come back, then what will happen? It will not get, okay, its original shape, no? If it remains high, what will happen? It will not come back to its original shape. Clear? So the transverse wave requires solid, because solid molecules are what? Tightly packed. Okay, so if, okay, one molecule is trying to go up, okay, what will happen? Other will try to nothing but, okay, what? Pull it together, that is okay there. So that's why in solid these waves can propagate. But in liquid, what will happen? Liquid do not have any definite shape. We discussed, okay, liquid has what? No definite shape. Last class we discussed, if you put water in what? Glass, it will acquire a shape of glass. If you put water in a vessel, what will happen? It will acquire a shape of vessel. Liquid do not have any definite shape. When it do not have any definite shape, what will happen? The, okay, waves cannot travel in the case of nothing but, okay, what? In the case of liquid and gaseous medium. Gas, okay, as we discussed, gas do not have any shape also. Gas do not have any fixed volume also. Liquid has a fixed volume, but gas do not have that volume also. So that's why the transverse wave cannot travel through what? Liquid and gas. So if, let's say, if any part of earth interior is of liquid, then what will happen? If the transverse wave is generated, then transverse wave will not travel in the liquid. When it will not travel in the liquid, it will not be arriving at this junction. Clear? The waves will not arrive at this junction on the surface, that is okay there, because it has to pass through liquid region, and in liquid it can't travel, so it will not arrive in what? Arrive at this region. Let's say this part is not containing in liquid, it can travel through this path and can arrive at what? Can arrive at nothing but, okay, this particular region. Waves can arrive at this particular region. Clear? So this is how studying the waves, from where the waves are something that are coming, what type of waves are coming. The seismic waves can be of various types. Later on we will discuss earthquake in detail, like P wave, primary wave or secondary wave. They can be of different types. So which wave we are receiving, that can give you information regarding what? That can give you information regarding interior of Earth. Clear? Any doubt? Whether interior of Earth is solid, interior of Earth is liquid, interior of Earth is in gaseous manner. This information can be given through nothing but, okay, studying these waves, because waves can travel through solid. If it is a longitudinal wave, like P wave can travel through all three medium. S wave can travel only through S wave can only travel through solid medium. So if P wave is arriving over here, or if S wave is, okay, arriving over here, not arriving over here, we'll say that, okay, this part is okay, what? This part is, okay, traveling through liquid part or gaseous part. So that is how we get information regarding interior of Earth. Clear? So by studying the waves, we get information regarding interior of Earth, whether it is a solid one, whether it is liquid one, whether it is molten one, viscous one. Those things you have to keep in mind. Clear? Next is, okay, what? Next is, okay, gravitation. So what is basically gravitation? Just now we discussed in the last class that gravity is maximum where? Where do you see maximum gravity? Poles. Okay, you see maximum gravity at poles. Minimum gravity where? At the equator. Why? Because we discussed gravity is equals to what? Gm by r square, and we discussed, okay, here the radius is more, here the radius is what? Less, because Earth is flattened at poles and bulging out at the equator. So that's why you see gravity distribution is different. Also, gravity is also dependent on whom? Gravity is also dependent on whom? Mass. It is also dependent on not only radius, it is also dependent on what? Mass. Let's say more mass of the Earth is concentrated over here, then what will happen? More mass is concentrated, then what will happen? Gravity will be more. If less mass is concentrated over here, then what will happen? Gravity will be nothing but, okay, less over here. Clear? So this also gives, studying gravity also gives you information that where the mass of the earth is more, where the mass of earth is less. Because okay, higher mass indicate what? Higher gravity, lesser mass indicate what? Lesser gravity. So by studying the mass also, you can by studying the gravity also, you can find the distribution of mass inside the earth, that is okay there. So this is also giving you information regarding what? Interior of earth. We can deduce the information. The last thing that we have is what? Magnetic field. Okay, so magnetic field also gives you information. Yeah. So earth acts like a magnet. Why earth act like a magnet?
Gravity.
Because Earth's core is consisting of iron. Okay, Earth's core is consisting of iron, and you know that iron is what? Magnetic property. Iron has a magnetic property. So by studying the magnetic field, magnetic properties of the Earth, you can also deduce information regarding Earth's interior. Clear? So these are what? These are not directly giving you information, but you can study this and you can deduce that similar thing is okay happening inside the Earth. But these are giving you direct information regarding interior of Earth. Okay, so that's why in prelims you might get a question like which of the following is what? Which of the following is a sources to study the interior, or direct sources to study the interior of Earth, or indirect sources to study the interior of Earth. Okay, they might give you volcanic eruption, earthquake, and meteors as an example, as an option, and ask you which of the following is what? Which of the following is a direct sources to study the interior of Earth. So you are going to choose what? Volcanic eruption as one of the sources to study the interior of Earth. Clear? So as we discussed, Earth is in which shape? Earth is in spheroid shape. Now we are taking a cross section of Earth. So this is okay, radius of Earth. This is okay, the center of the Earth. This is a radius of Earth. Now we are taking this cross section of Earth and we are trying to study the interior part of the Earth. Clear? Clear? So this is the crust, mantle and core. These are the three parts. We are taking a cross section of Earth like this, and we are trying to study what lies in the interior of Earth. So three layers we are classifying: core, mantle and crust. Generally 0 to 60 kilometer is the extension of what? Extension of crust. From 60 kilometer to 2900 kilometer, you are seeing okay the mantle, upper mantle and lower mantle, and from 2009 to almost roughly around 6300 kilometer, you will see core extension. Clear? Now, this part. So there are certain discontinuity also existing, which are Conrad discontinuity, Moho discontinuity, the Gutenberg discontinuity, Hammond discontinuity. These are different type of discontinuity that you are also finding.
So is there 60 kilometer in the first one?
60, yes. 60. This one more discontinuity, this part. So there is a Conrad discontinuity, there is a Moho discontinuity, Repeti discontinuity, then Gutenberg discontinuity, Lehman discontinuity. These discontinuity can be classified into major and minor. Major and minor. Lehman is minor, Repeti is minor, Conrad is minor, Moho and Gutenberg are called as a major discontinuity. Clear? What?
Just a minute, sir.
So Conrad is in the crust.
Yeah, in the crust. The dotted line indicate the Conrad discontinuity. The dotted line is there. This dotted line indicates the Conrad discontinuity. Now, there is another division.
You have to erase it with pencil. Pen, pen.
Pen.
Yeah.
Okay, pen. So there is another classification where 0 to 100 kilometer is called as what? Lithosphere. Almost 100 to 200 kilometer is called as what? Asthenosphere. Then this region is referred as a mesosphere. And this region is referred as a bathysphere. This region is referred as a bathysphere. Generally, the core region is called as a bathysphere. The lower mantle region is called as a mesosphere. Clear? Now, so Earth interior can be classified like this, or Earth interior can be classified like this. Now, these are referred as mechanical classification. Mechanical classification. And these are generally referred as, okay, what? The chemical classification. So this part is referred as a chemical classification of Earth interior. This part referred as a mechanical classification of Earth interior. Mechanical classification, bathysphere, can also be classified, as we discussed, into outer core and inner core part. It can also be classified into outer core and inner core part. What is a mechanical classification means? What the term mechanical classification means?
Structure of the
Structure of
the elevator.
anyone else? What does the term mechanical classification means?
How involved and where all the things physical.
Basically, mechanical classification talks about the mechanical pressure. When you are applying a stress, when you are applying something on the earth, how it is behaving, it is called as nothing but a mechanical classification. So generally, it talks about matter in the state, whether it is in solid state, whether it is in liquid state, whether it is in gaseous state, in which type it is existing, then it is called as a which type of classification? Mechanical classification. So mechanical classification basically talks about the stress that you are giving, and because of this stress, because of this pressure, how the material is behaving, whether it is behaving in a solid state, whether it is in liquid state, how the material is something that is okay behaving, that is called as a mechanical classification. Clear? Second type of classification is a chemical classification. What is chemical classification?
Formation.
Depending upon composition, whether core is consisting of which metal, the mantle is consisting of which metal, or crust is consisting of which metal. That type of classification is referred as a chemical classification. So we have two classifications. One is called as a mechanical classification, and another is called as a chemical classification to study the interior of Earth. Clear? Now, the first that you are finding is the first part that you are finding is a lithosphere. So generally, the top part of the Earth from 0 to 100 kilometer is referred as what? Is referred as a lithosphere. This lithosphere is a solid part of the Earth. Solid part of the Earth. So the solid part of the Earth, the upper part of the Earth, the solid part of the Earth is referred as what? Is referred as a lithosphere. Clear? Now lithosphere extends from where to where? 0 to 100 kilometers. So 0 to 100 kilometers means what? It includes crust part also, and it is including what? Upper part of mantle also. So it is including the crust plus upper mantle. Upper mantle region. This comes under what? This comes under lithosphere. Clear? So lithosphere is a solid part of the Earth. Since lithosphere is extending from 0 to 100 kilometer, it includes crust, which is up to 60 kilometer, and beyond crust is upper part of mantle, which is nothing but another 40 kilometer. This part is called as a solid part of the Earth. Clear? Any doubt regarding this particular thing? Now, this lithosphere, this solid block of the Earth, this is a solid block of the Earth. This is not a continuous solid block. This is not a continuous solid block. Continuous solid block means what? Like this surface, okay? Continuous table is there, no? From here to here, it is extending from this range to this range. This is a continuous block, okay? But lithosphere is not like a continuous block. It is broken down. It is broken down into various, okay, what? Various nothing but, okay, region, like this. It is broken down like this. Okay? So because of this broken down, you will find like this. So lithosphere is existing like this. It is broken down. It is not a continuous solid block. It is broken down, and this broken part is referred as what? Plates. These parts are referred as what? These parts are referred as the plates. So you can have a bigger plate also. You can have, okay, what? Smaller plate also. Bigger plates are referred as what? Major plate and the minor plates. Yes. So lithosphere is not a continuous solid block. It is, okay, broken down into various, okay, what? Various sections, and these solid blocks are referred as a plates. These can be major plate or these can be minor plates. Now the second part that you have is what? Is the asthenosphere. So the second part that you have is the asthenosphere, which is lying below lithosphere. This lies below lithosphere. Clear? Now assume that this is, okay, what? This is, okay, the surface. If I put a weight on this, what will happen? It will not. I put a weight on this, what will happen? This will feel a pressure, the bottom thing. If I put a much bigger weight, then what will happen? Okay, what will happen? More weight are going to be there. So the lower part, the asthenosphere part, is facing the weight of lithosphere. It is facing the weight of lithosphere. That's why asthenosphere is not in, okay, solid state, because of the pressure that it is facing. It is in which state? It is in plastic state. Okay, it is in which state? It is in plastic state. It is in which state? It is in plastic state. So because, okay, plastics allows you what? Like this surface, okay, if it is plastic, then what will happen? Less frictions are something that are there. Clear? So because of this less friction, plate is able to move on what? Plate is able to move on asthenosphere. Clear? So we discussed lithosphere is what? Lithosphere is a plate. Below this plate which lies which layer? Lies your asthenosphere. Now this asthenosphere is in which state? Plastic state. Doesn't create much of friction, because if two solid surfaces are there, then what will happen? It will create more friction. If it is in plastic state, create less friction. As a result, okay, this plate is able to move this direction. This plate is able to move in this direction. Or this plate is able to move in this direction. This plate is able to move in this direction. So the plates are continuously moving over what? Continuously moving over asthenosphere. Clear? Any doubt regarding this one? And what is the reason for nothing but, okay, plate movement? What is the reason for this plate movement? Why plate is able to move over asthenosphere? It is because of, okay, some convectional current that is generated in this region. It is because of convection current that is generated in mantle region. Because of this, plates are able to move. Because of this, plates are able to move. If this convectional current are moving apart like this, if the convection current are moving apart like this, then what will happen? They will take the plates away from each other. If the convection current are moving like this, closer to it, so they will bring the plates towards each other. Clear? Like, let's say this is the surface, this part is, okay, plates. Now what will happen if convectional current is moving like this? Okay, if convectional current is moving like this, then the plate will also move, okay, where? In this direction. If the convectional current is, okay, what? Moving in this direction, plate will also move in this particular direction. So this convectional current that is generated in the mantle region is responsible for the plate movement. Okay, clear? And this plate movement is also the result of what? This plate movement is causing your volcanic eruption, or this plate movement is causing your earthquake, okay, to be generated. Clear? Any doubt regarding this one? So what you have to keep in mind, what is lithosphere? It is a solid block of the earth, continuous. It is not in continuous form. It is broken down into many plates, and these can be major plates or these can be minor plates. Below, okay, what? Below the lithosphere, you will have a layer of what? Layer of asthenosphere, An asthenosphere allows, okay, provide lesser friction. That's why allows the movement of nothing but okay plates. And why plate movement are there? Because of due to convectional current that are generated in the mantle region. Clear? Now, what is convection basically? Can you understand? Can you define the term convection? Because this is convectional current. Can you define the term convection?
Towards one direction.
Towards one direction. Anyone else? Anyone else? What is convection basically? Because of the heat, yes. Okay, it is generated because of heat. Any other thing? Anyone else? Now, there are three ways in which heat can transfer. So heat moves from what? Heat move. Heat is a energy. This energy moves from higher body temperature to lower body temperature. Always heat has a directional flow. It always moves from where to where? Higher body temperature to lower body temperature. And this transfer of heat can happen with certain forms. This transfer of heat can happen in certain forms. And these transfer of heat is called as what? Conduction, convection, and radiations. So transfer of heat can happen in these forms, which are conduction, convection, as well as radiations. Clear? What is conduction? What is conduction? Conduction, convection, and radiation. What is conduction? Conduction happens in solid. This happens in solid. This happens in fluids. That is, fluids are liquid and gases. So conduction happens in solid. Convection happens in fluid, which is liquid and gases. And radiation happens in what? Radiation happens in without any medium. This happens without any medium. When heat transfer happens without any medium, without any solid, liquid or gaseous medium, then such type of, okay, what thing is called as what? That such type of things is called as a radiation. Like, remember just now we discussed solar radiation or terrestrial radiation. Okay? So when earth is radiating, we call it as what? Terrestrial radiation. When sun's radiation is coming, it's called as a solar radiation. Why? Because in the space vacuum is there, mediums are not there. So what will happen? Sun's rays has to come, heat has to come. So this heat comes in the form of what? Radiation. So when heat is okay transfer happening without any medium, then such type of okay things is called as what? Such type of things are called as a radiations. Clear? Any doubt?
Conduction, meaning of conduction.
We are coming to conduction. So radiation is what? Radiation means heat transfer will happen without any medium. Clear? Now what is conduction? Now conduction happens in a solid. Okay, we have just now said conduction happens in a solid. In solid, what is happening? Molecules are closely packed. Molecules are something that are closely packed. Okay, these are how the molecules are. Okay, closely packed. They are placed closer to each other. Clear? Now, if I provide heat to this molecule, this part of okay substance, what will happen? It will starts to vibrate. Okay, it will starts to vibrate. Clear? So it will starts to vibrate. Now this is how okay things are something that are packed. Okay, now this part is okay. Assume this is okay. What? This is where I am heat providing. So what will happen to this one? It will starts to vibrate. Now it will starts to vibrate. Then it is going to collide with whom? Collide with this part. So heat transfer will happen from here to here. Now this will starts to collide. What will happen? Heat transfer will happen from here to here. Now this will collide with this. Heat transfer will now happen from here to here. Now happen from here to here. So this is how conduction process happens. Clear? For example, okay, you put something on your gas stove. What happens? You are providing heat where? You are providing heat over here. Initially, when you put the top of the vessel will not be hot. But okay, over a period of time, what will happen? Top of the vessel also becomes hot. No? How it happened? Because heat transfer happens. Molecule transfer heat from here to here. That is how the top of the vessel also becomes something but okay hot. Clear? So this is how the conduction happens. Heat transfer happens. Okay. Why heat transfer happens? Because molecules are closely packed and they start something but okay vibrate. And that is how collision lead to nothing but okay transfer of heat. Clear? Now this is what we call as a conduction process. Clear? Now, so in conduction process, molecules are not moving. They are not moving. They are there at their places only. This is only vibrating at where? At its place. This is only vibrating at where? At its place. This is only vibrating where? At its place. So this molecule which is over here is not moving over here. This is not moving over here. It remains at this place only. That is okay there. So in the conduction there is no actual movement of food. There is no actual movement of molecules. Molecules will not move from one place to another place. They will just vibrate on their particular positions. Okay, that is okay there. So this is how, okay, you see transfer of heat happens in the case of conduction. Clear? In convection, there will be movement of molecules. There will be movement of molecules. Now suppose the same concept you take a gas stove, put vessels in this. Now you are putting water in this. Now you are water in this particular vessel. What will happen now? You will see, okay, this part will get heated. When this get heated, it will come up, bubbles will come up. You will see bubbles coming up. And okay, the part which is okay, which is not heated will move down. This part will move down. And again this will get heated, this will come up, okay, that is okay there. So there will be actual movement of what? Actual movement of molecules are happening from the bottom to the top. And this process is referred as what? This process is referred as a convectional current. Clear? Any doubt? So that's why you see here what is happening? Convectional currents are being formed. And when this convectional current are going up, this convectional current only comes in the form of what? Let's say this comes onto the surface, then it comes in the form of what? Volcanic eruptions. So in volcanic eruption, you see materials comes out from what? From the surface of what? Why material comes out? Because molecules movement are there from nothing but okay, bottom to the top. So this is okay what happens in the case of nothing but okay, interior of Earth. Okay, so this movement of okay, what? Movement of molecules or this movement of okay plates is happening due to what? Due to convectional current generated in the metal. When this convectional current becomes very strong, they comes out in the form of what? In the form of volcanic eruptions. Clear? Any doubt regarding this particular thing? The third thing that you have is a mesosphere. The third layer that you have is a mesosphere. Lower part, okay, lower part of okay what? Lower part of the asthenosphere or lower part of mantle that you find is a mesosphere. Now this mesosphere is generally in solid state, okay? This is generally in solid state, okay? Or which, okay, sometimes okay we say molten, okay, molten form or broken form, okay? You'll find this particular thing, clear? So okay, because of some certain area convectional current, it can be in what? It can be in molten form also, and it can also in certain part as a solid form also, clear? So that is what we are finding with regard to mesosphere. Then you have core. Core is, as we discussed, divided into outer core and inner core. The outer core is in which state? It is in liquid state. While inner core is in which state? Solid state. So outer core is in which state? It is in liquid state, while inner core is in solid state. Clear? So these are okay different state okay that you are finding. Clear? Now why outer core is in liquid state? Why inner core is in solid state? Why outer core is in liquid state, while inner core is in solid state? Temperature. Temperature causes what?
Pressure.
The heavier, denser material.
Centrifugal force.
Centrifugal force. Okay. But we are saying mantle is in which state? Mantle could be in solid state. Can be? Mantles are in solid state, like we discussed. Mesosphere, lower part can be in solid state. So if it is in solid, why do you see outer core is in liquid state?
There is where the magma and everything are present.
There the magma and everything are present. Okay. Anyone else? Or else okay reason do you find that the outer core is in liquid state? Let's say water is there. You want to convert water into ice. What you will do to convert water into ice? You will reduce the temperature. You will reduce the temperature to its freezing point, and then water will convert into what? Ice. So reduction of temperature is being done. The second thing that you see is what? The second thing that you see is okay, if you change the pressure, then what will happen? So one way to convert water into okay, this is change the temperature. Another is okay, you can change pressure also. If you change pressure, what will happen? If you change pressure, what will happen? If you change pressure, for example, as you go up, you have heard about this statement that is, as you go up, cooking becomes difficult. Why cooking becomes difficult in mountains and etc.? Because pressure decreases. Atmospheric pressure is decreasing because as you go up, there is a less gases that are present. Atmosphere is more denser near the Earth's surface. As you go up, it becomes thinner and thinner. So as you go up, cooking becomes very difficult. Why cooking becomes difficult? Because the pressure is pressure is nothing but lesser over there. When pressure is lesser, what will happen? You are not reaching to nothing but you are not reaching to nothing but higher pressure, and that's why it's difficult to cook things at that particular level. So another thing that you see is pressure also can affect pressure can also affect your boiling point. Pressure can also affect your melting point. Clear? So like temperature is affecting your boiling point and melting point, like that pressure can also affect your boiling point and melting point. That is there. Clear? Any doubt regarding this one? That's why when lesser gases are there, boiling happens very quickly. When boiling happens very quickly, it is difficult to nothing but cook things. That is they take longer time to cook because things do not get properly boiled over higher temperature. Clear? So pressure also impact your boiling point as well as melting points. Clear? Now when we are putting this much pressure, like we are putting the crust pressure also, mantle pressure also on the core. Now because of this pressure, what will happen? Melting point will change. Melting point will change, and that's why core is in which state? Core is in a liquid state. Because of additional pressure of nothing but crust as well as mantle, the melting point of nothing but melting point of substance are going to change, and as a result, core is in which state? Outer core is in which state? Liquid state. But when we come to the inner core, again what will happen? Again there is a outer core pressure also on outer core pressure also on inner core. So this pressure also get added, no? This weight also get added on the inner core. That's why inner core is in which state? It is in solid state. So inner core is in which state? It is in solid state. Clear? Any doubt regarding this particular thing? Not understanding. What we discussed is we discussed melting point and boiling point can also be impacted by what? Pressure, not only temperature. So temperature do affect melting and boiling point. Like that, pressure can also impact melting and boiling point. Higher pressure means what?
Lower temperature.
Higher pressure means lower temperature. Temperature will be nothing but lower. Clear? So when temperature are going to be lower, what will happen? When temperature are going to be lower, what will happen? You will see things are going to come together. No, if I apply pressure on this one, what will happen? Let's say if I apply pressure on this one, what will happen? Compression will happen. They will come closer to each other. Come closer to each other means they should be in which state? Solid state. They should be in which state? Solid state. But if this pressure is not that much enough, then it is going to be in which state? Liquid state. So outer core is in which state? Liquid state. Why? Because the pressure of pressure of nothing but crust and mantle is not that enough. Not enough to melt it or to compress it into which state? Solid state. But when we are coming to which part? The inner core part, what is happening? Now crust pressure is also there, mantle pressure is also there, outer core pressure is also there. So because of this, what will happen? More pressure. More pressure means what? More compression. More compression means what? They will come in which state? Solid state. So that's why inner core is in which state? It is in solid state, while outer core is in which state? Liquid state. Clear? Any doubt regarding this particular thing? So this is important point you have to keep in mind. Clear? So this classification is referred as what? This classification is referred as a mechanical classification.
So why isn't hydrosphere included?
Why there is a
Hydrosphere is not included.
hydrosphere is like crust itself is classified into what? Crust itself is classified into oceanic crust and continental crust. So crust itself because these are present, water is present on the surface. So that's why crust itself is classified into oceanic crust and continental crust. So that is it. So this this is what you are finding with regard to the lithosphere. Then you are finding what? Asthenosphere. Then you are finding what? Mesosphere. Then you are finding barysphere. Barysphere means core part, which is outer core and inner core. Clear? Any doubt regarding this one? So we discussed lithosphere is what? Lithosphere is a solid part, It is not continuous solid, rather broken down into plates. That is major plates and minor plate. It is moving over. These plates are moving over which layer? These plates are moving over astrosphere. Why they are moving over astrosphere? Because of the convectional current that are generated in which region? That are generated in the mantle region. Convectional current that are generated in the mantle region. Why? What is convection? We discussed convection happens in which? It happens in a liquid or gaseous material, fluid material, and in convection what will happen? There is an actual movement of molecules that is okay there. So molecules are moving up, moving away, then coming down. This is okay cycle that is okay going up in the mantle region that is okay there. Clear? Then third stage is what? Mesosphere. Mesosphere is a lower part of nothing but okay what? Lower part of nothing but okay the mantle, and then you have outer core and inner core. Outer core is in which state? Outer core is in which state? It is in liquid state. Inner core is in which state? In solid state. Clear? Any doubt regarding this one? No? Anyone having any doubt? Now we are coming to the chemical classification part. So now we are coming to what? We are coming to the chemical classification part. So basically the crust, mantle and core has a different composition. Clear? Crust is generally made up of what? Crust is made up of generally silicon and aluminum. Okay? These are called as a silane. Okay? Crust is generally consisting of silicon and aluminum. That's why different chemical composition is there. The core generally is made up of what? The core generally is made up of nickel and iron. Core is called as a lead. Okay, this is generally made up of nickel and iron. Clear? So different chemical composition of core. Core is made up of nickel and iron. So it is made up of nickel as well as iron, outer core and inner core. Clear? And the mantle is something that is made up of sima, silicon and magnesium. Okay, so these are referred as sima. Clear? So different composition we are finding: silicon plus aluminum, silicon plus magnesium, as well as okay nickel plus iron. Clear? So outer core, the crust is made up of silicon plus aluminum. Mantle is generally made up of silicon, magnesium, and other element, and core is made up of nickel plus iron. Clear? Now, since they are made up of different material, what will happen? Since they are made up of different material, what will happen? They'll have different mass, different density. Clear? Density is what? Your mass by volume. Density, how you calculate? Density you calculate by mass by volume. So density is mass by volume. For example, let's say this chair. This chair is made up of different material. This table is made up of what? Different material. Both are solid, but both are made up of what? Different material. That's why they have what? This has different weight. This has nothing but okay different weight. So when you have okay substance made up of different material, what will happen? They'll have okay what? They'll have different density. They'll have different density. So that's why when you move from where to where? That's why when you move from where to where? When you move from nothing but okay crust towards mantle, what will happen? Change in density will occur. No? When you are moving from crust to mantle, what will happen? Change in density will occur because this is made up of different material, this is made up of different material. So that's why this change in okay what? Change in things is called as what? Discontinuity. This change is called as what? Discontinuity. And since you are moving from crust to the mantle, change in composition is happening. This change in composition is a major change, and that's why it is called as which discontinuity? Major discontinuity. So between crust and mantle, which discontinuity occur? Moho discontinuity. Between crust and mantle, which discontinuity occur? Moho discontinuity. Similarly, you are seeing okay, this is a mantle part, this is a core part. As we discussed, core is consisting of nickel and iron. So what will happen? Again, change in density, change in material will happen. So that's why this discontinuity is referred as what? This discontinuity is referred as a Gutenberg discontinuity. It is again okay, which type of discontinuity? Major discontinuity. So this is Gutenberg discontinuity. Again, which type of discontinuity? Major discontinuity. So between crust and mantle, there is a discontinuity because of change, and this discontinuity is called as a Moho discontinuity. Between mantle and core, there is a change in material, change in weight, change in density, and this is referred as what? This is referred as a Gutenberg discontinuity. Clear? Any doubt regarding this one? So why we are writing here is a major one, because there is a change in composition, that is there. Clear? But within crust also you are seeing nothing but certain variation. Within crust also you are seeing certain variation, and this discontinuity is called as what? Cone wrap discontinuity or minor discontinuity. So we have written this particular dotted line. This dotted line is indicating which type of discontinuity? Minor discontinuity, cone wrap discontinuity. Now why within crust, why there is a discontinuity? Within crust, why there is a discontinuity? As we discussed, density is what? Density is what? Mass by volume. Density is mass by volume. Clear? Now what will happen to volume when you are taking nothing but what? When you are taking this region. So how do you calculate volume? Like you have studied in maths. What is the volume of sphere? This is the volume of sphere. Volume of sphere is what? 4 by 3 pi r cube. This is the volume of sphere. Assume Earth as a sphere. Though we discussed Earth is not fully sphere, it is in geoid shape, but assume that it is in a sphere. So what is the radius? Radius is of Earth, we have discussed, it is around 6,300 kilometers. This is the radius of Earth, we have discussed. So when you are taking this much region, what will happen? It reduces. When you are taking till here, what is happening? So from here to here, from this point to the top, how much is the distance? That is a 6300 kilometer. But when you are taking from here till here, what will happen? Radius will reduce. If radius reduces, then what will happen? What will happen to density? If radius reduces, volume reduces. Volume reduces, what will happen? Density will what? Density will nothing but change. Density will change. Clear? And if this density change, then what will happen? Discontinuity will arise, and this is going to be called as which type of discontinuity? Cone wrap discontinuity. Clear? So within crust also certain minor changes in density can be observed. And this type of discontinuity is called as what? This type of discontinuity is called as a which type of discontinuity? Cone wrap discontinuity. Now why this is occurring? This is occurring because of what? This is occurring because of change in radius. If radius changes, then what will happen? Volume changes. If volume changes, then what will happen? Density will change. So that's why minor changes will also be seen in this region. And this type of discontinuity is referred as what? Cone wrap discontinuity. Clear? Similar thing also happens in case of nothing but mantle region. So that's why the minor discontinuity is referred here as what? Repeti discontinuity. And similar change will also happen over here. And this minor discontinuity between outer core and inner core is referred as what? Is referred as a Lehmann discontinuity. Clear? So where do you observe major discontinuity? Major discontinuity is when you are moving from crust towards mantle, or when you are moving from mantle towards core, you are going to observe major discontinuity. Why major discontinuity? Why major discontinuity?
Volume.
Because change in material. What is happening? We discussed crust is made up of what? Silicon and aluminum. Mantle is made up of what? Silicon, magnesium. It is made up of what? Nickel and iron. So if material changes, what will happen? Density will change. Like we discussed table and chair example. So table is what? More weight, more denser than the chair that you have. Clear? Why? Because it is consisting of different materials. So that's why you have you have change in material. That's why we have written here what? Which type of discontinuity? Major discontinuity. But within crust also there will be change in density. Within mantle also there will be change in density, and within core also there will be change in density. This change in density is mainly due to nothing but due to nothing but change in volume. This volume, as we discussed, density is mass by volume. If volume decline, what will happen? Density will nothing but decline. And that's why we observe minor discontinuity, cone wrap discontinuity, Repeti discontinuity, Lehmann discontinuity. These are referred as a minor discontinuity. Clear? So these differentiation you keep in mind why this discontinuity is observed. So in prelims you might get a question like this. Let's say you get a question like this. Which is the answer? Which pair is correctly matched? No? Gutenberg, it lies where?
Low mantle and
It lies between mantle and core. It doesn't lie between crust and mantle. Which lies between crust and mantle? Mono discontinuity. So mono discontinuity lies between crust and mantle. Gutenberg lies between mantle and core. So first is wrongly matched. Mo is also wrongly matched because we are saying that it is okay between crust and mantle, not between outer crust and inner crust. So this is also wrongly matched. Repeti discontinuity is what? Upper mantle and lower mantle. So this part is what? This part is correctly matched. Okay. So there is no option given as 3 only. So answer will be what? Answer will be none of the above. Okay. So none of the above is something that is okay, correctly okay given in this particular question. Clear? Any doubt? So like this, okay, you'll get a question in the case of examination. So remember that which discontinuity is occurring in which region. Fine? Any doubt? So this okay type of discontinuity type of question you can get in the case of prelims examination. Clear? Now another part that you are seeing over here, this is okay what? As we discussed, crust part. Now the crust is divided into what? As we discussed, crust is divided into 2 parts. One is outer crust and another is called as a inner crust. So let's say this particular part we are taking up, okay, this is a crust part and this crust part is divided into outer crust as well as inner crust. Now, this crust can also be divided into 2 different parts. One is called as a oceanic crust, another is called as a continental crust. Continental crust. Oceanic crust and continental crust. Because okay, on the crust you are also finding oceans, water, and at the water, base of the water, what you are going to find? You are going to find okay, oceanic bed. So this contains certain okay what? Certain muds, certain rocks, okay, certain other things. So this is where you will find okay what? This is where you will find oceanic crust. And this where you will finding mountains, you are finding plains. So this where you will find what? Continental crust. So which one is more thicker, oceanic or continental? Oceanic crust is more thicker or continental crust is more thicker? Ocean. Why?
heavy metal.
Now let's say this is okay what? This is nothing but okay your inner crust and this is nothing but okay your outer crust. Clear? Now here the thickness, this is okay what? Thickness is extending from here to here. But here the thickness is only extending from where to where? From here to here, because here is a water. Okay, it is not containing any rocks and etc. It is containing water. So thickness of what? Thickness of continental crust is what? More. Thickness of oceanic crust is what? Less. Clear? Thickness of oceanic crust is less. Thickness of continental crust is more. Clear? So continental crust is having more. So generally continental crust you can see it extends from 5 to 60 kilometers. Okay, it can extend from nothing but okay more area. It can extend 5 to 60 kilometers. Oceanic crust is smaller in nature. Thickness is something that is okay smaller in nature. So continental crust is what? More thicker than the oceanic crust. Clear? Any doubt? Now the second thing that you have to keep in mind is continental crust is made up of what we call as a felsic rocks, while the oceanic crust is something that is made up of mafic rock. So continental crust is something that is said to be consisting of which type of rock? Felsic rock, while oceanic crust is said to be consisting of which type of rock? Mafic rock. What is felsic rock? Rocks, these are containing lighter element of like sodium, potassium, silicate. So the sodium lighter element like sodium, potassium, silicate, these are referred as what? These are referred as a felsic rock. While the heavier one, that is iron, magnesium, these silicates are what? These silicates are referred as a mafic rocks. Okay, these are referred as what? These are nothing but okay, referred as a mafic rock. So continental crust is made up of which type of rock? Felsic rock. Oceanic crust is made up of which type of rock? It is made up of mafic rock. Clear? Now, which we discuss mafic rocks are which one? Heavier. Continental are what? Lighter in nature. So which will be more denser? Which one is more denser? Heavier one. Okay, because we discussed density is what? Mass by volume. So the more mass means what will happen? More denser, okay, it is going to be there. So which is going to be more denser? Oceanic crust or continental crust? Which is going to be more denser? Oceanic crust or continental crust? Oceanic crust, okay, because oceanic crust is heavier in nature, it has a more mass. So oceanic crust is what? More denser as compared to continental crust. So what difference you are finding between these two crusts? What difference you are finding between these two crusts? So you have oceanic crust and you have what? Continental crust. We discussed continental crust is more thicker, while oceanic crust is what? Thinner. Continental crust is what? Less denser. Oceanic crust is what? More denser. Continental crust is what? Made up of which type of rock? Felsic rock. Oceanic crust is made up of which type of rock? Mafic rock. So this is okay, basically difference you are finding between what? Oceanic crust and continental crust. So the crust itself is made up of two types, oceanic crust and continental crust, and this is the difference you are finding between the oceanic crust as well as continental crust. Clear? So just note down these 3 points regarding oceanic crust and continental crust. Done? So as we discussed, crust is extending from where to where? From 0 to 60 kilometer. This 0 to 60 kilometer also contains what? Oceanic crust. This also contains nothing but okay, continental crust. This upper part is called as the outer crust. This lower part is called as the inner crust. Okay, this lower part is called as the inner crust. And we discussed till 0 to how much kilometer? Till 0 to 100 kilometer you have what? Solid part, which is a lithosphere. Clear? Now the second part that you have is a mantle region. The second part that you have is a mantle region. Now crust basically is very small. You can see this is okay, only extending from where to where? 0 to 60 kilometer. It is mantle that is extending from where to where? From 60 to 2900 and 2900 to 6300. We have discussed okay, what we discussed core is there. Okay, 2900 to 6300 core is there. So the maximum part okay of earth okay that you are seeing, the maximum part of the earth that you are seeing is made up of what? Is made up of nothing but okay core, which is extending in okay much larger amount, or okay you are seeing nothing but okay in the form of mantle. Crust is very small part. Clear? Any doubt regarding this one? So that's why crust do not constitute much of volume or much of mass. They neither constitute much of volume of earth, neither constitute much of mass of the earth. Why? Because the heavier element is where? Mass is where? Here. Nickel and iron is okay, heavier element. Because here we discuss it is made up of what? Silicon and aluminium. Remember periodic table? We discuss hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. Sodium is okay, 11th in the atomic number that you are finding. Clear? So these are okay, what? These are made up of silicate rock. Silicate rock, okay, as we discussed, it can be either iron, magnesium, it can be either nothing but okay, what? Okay, the sodium, potassium. So what you find is these are okay, what? These are very okay, constituting very less mass and very less volume of the earth. The more mass and more volume comes from where? From the mantle and core region. Okay, because they are extending from here to here, they are extending from here to here. Clear? Now, when we are moving from crust towards mantle, as we discussed, mantle is further divided into what? Upper mantle and lower mantle region. Upper mantle and lower mantle region. Clear? Much of convectional current, much of the convectional current which we discussed generated is where it is in this region. Yes, okay. It is in upper mantle region. Much of convectional current, okay, generated is in upper mantle region. Upper mantle generally extend up to 650, 700 kilometer. So from 100 kilometer to 650 to 700, you will find upper mantle. Rest are nothing but okay, lower mantle. So much of the convectional current we talked about is generated where? It is generated in the upper mantle region. So this is okay, the crust part. This is nothing but okay, upper mantle region. As we discussed here, convectional current are generated. As we discussed, when this convectional current are not strong enough, they make a cycle like this. But when they are strong enough, they are able to break this particular surface and comes out in the form of what? In the form of volcanic eruption. Yeah. So this discontinuity between upper and lower mantle, we just now discussed is which type of discontinuity? It is nothing but okay, repetitive discontinuity. So we discussed discontinuity between upper and lower mantle is referred as which type of discontinuity? Repetitive discontinuity. Clear? Now, as we are moving from here to here, from crust to mantle, what will happen in the temperature? What change you are going to find in temperature? Temperature increases. Why do you think it will increase? Compression, kind of. Anyone else? Why do you think the temperature will increase?
Pressure.
Yes. Temperature is increasing because of both reasons. As we discussed here, what is happening? How the convectional current are generated? How the convectional current are generated? Because of heat. From where heat is being released? Okay, from the radioactive material. You know that Earth contains various radioactive material, uranium, thorium, all these things you are deriving from where? From the Earth. Okay, these radioactive materials are going to decay. When these are going to decay, what will happen? They are going to generate heat. So this heat is okay responsible for what? This heat is responsible for the convectional current that are generated in the mantle region. Clear? So when we are moving from crust to the mantle, temperature is what? Temperature is going to increase. Clear? Now that's why there are two sources of heat. There are two sources of heat. We say one is sun's heat and another is called as what? Another is called as a Earth's heat. So sun's heat is responsible for what? Sun's heat is responsible for what? All your weather phenomena. Okay, so why cyclones are occurring, why wind is blowing, why okay your rainfall is occurring, all these phenomena is occurring because of what? Because of sun's heat. And what is okay phenomena occurring due to Earth's heat? Volcanic eruption, earthquake, okay, movement of plates, all these phenomena is occurring due to what? Earth's heat, that is okay there. Clear? So sun's heat is okay generated because of what? Sun's heat are generated because of what? Because of fusion process. Earth's heat is generated because of what? Radioactive process. Clear? Any doubt regarding this one? So whatever the phenomena that is taking place above the surface of Earth is okay occurring due to what? Occurring due to majorly due to sun's heat. Whatever phenomena that is occurring below the surface of Earth, majorly occurring due to nothing but okay, Earth's heat. And Earth's heat is coming from radioactive decay, sun's heat is coming from nuclear fusion process. So that you have to keep in mind. Clear? So as we are moving from crust towards nothing but okay, the mantle region, you'll see what? You'll see nothing but okay, increasing temperatures. So you'll see increase in temperature. What else you'll see? Increase in what? Increase in pressure also. Why increase in pressure? Why increase in pressure? Already, okay, now mantle have okay additional layer of crust. Now if I put something heavier object over here, what will happen? This will feel the weight. This will feel nothing but okay pressure. Clear? So if I am going to put okay this particular substance on the okay what on the this thing, what will happen? This will feel the pressure. Okay, so when this will feel the pressure, what will happen? Okay, there will be increase in what? Increase in pressure also. So mantle region already have a burden of crust region. So that's why increase in pressure will also be there. Clear? The third thing, increase in what? Increase in density. So there will be also increase in what? Density, because we discussed okay this is made up of what? Silicon aluminum. This is majorly made up of what? Silicon and magnesium. So material change is happening. When material change is happening, density will change. So there will also be increase in what? Increase in nothing but okay density. So when you are moving from nothing but okay what? When you are moving from nothing but okay crust towards the mantle, you will find change in all these things, and that's why this is referred as what? Discontinuity. This is referred as what? Discontinuity. So as we discussed, okay, which discontinuity lies over here? Mono discontinuity. This discontinuity is called as a mono discontinuity. Clear? Now assume there is what you are digging. Okay, as we discussed, direct sources and indirect sources. Okay, so go back. So we discuss direct sources and indirect sources. Why we discuss deepest mine? Okay, is only this much. Deepest mine we discussed. Okay, Amponeng mines, which lies where in South Africa, and we discuss it is which mine? Gold mines. It is only around 3.9 kilometers. Why? As you go deeper, what is happening? Heat will increase. If heat will increase, what will happen? Survival of human will become what? Difficult, because you are digging up, you are going under the high heat. So survival of human becomes difficult. When survival of human becomes difficult, then what will happen? You will not be able to dig much deeper. So that's why deepest mines are not very deep. Okay, and that's why we say only around 4 kilometers deep only that you are finding. Because as you go deeper, what will happen? Temperature is going to increase. When temperature is going to increase, survival becomes difficult. Clear? Any doubt regarding this particular part? So this point, you are finding with regard to what? With regard to mantle region. So in detail, we'll start with mantle region in what? Mantle region in tomorrow's class. Okay. So we have covered till till the crust part. From mantle and core will start in tomorrow's. Okay. So what we try to cover today is what? First is what? Big Bang explosion. So what is Big Bang explosion? We discussed when explosion had happened from where? Singularity. After singularity, what will happen? After singularity, explosion. This explosion has created what? This explosion has created electrons and quarks. This explosion has created electrons and quarks. When quark is when further expansion is happening, cooling is happening, quark combines to form what? Neutrons and protons. This neutron and proton combines with whom? Atom. Electrons to form a atom. When atom is formed, then what will happen? You see formation of gases. Which gases are formed? Hydrogen and helium. Okay, then cloud of hydrogen and helium will create what? Nebula. This nebula, many nebula will create what? Galaxies. Okay, galaxies will then compress. Okay, you'll see formation of stars. Okay, as we discussed, stars have different what? Different life cycles. So we discussed which is the star. As we discussed, fusion process starts from where? Main sequence star, and then if it is a bigger star, it will go under this black hole formation or neutron star formation. If it is smaller star, it will go under this particular phase. And we discussed the small sun is which type of star? Sun is which type of star? Bigger or smaller? Smaller star. And we discussed when this explosion happened, this explosion will again create what? Dust and gases. This dust and gases will again lead to formation of nebula. So that's why we discussed death of a star is also leading to what? Birth of star. Okay, so a new star will form with nothing but a death of one star. Clear? So this is what we have discussed with regard to Big Bang explosion. Then we discussed whether interior of Earth. Interior of Earth is divided into what? The sources to study interior of Earth is divided into two parts. One is direct sources, and another is indirect sources. Gravitation is which kind of sources? It is an indirect source, yes. Okay, and volcanic eruption is which kind of sources? Direct sources. Clear? Then we also discussed the classification of interior of Earth. Interior of Earth is classified into two types. Okay, how do we classify? Chemical and mechanical classification. Chemical classification means based on composition. Mechanical classification means based on state of matters. Clear? So whether it is in solid state, whether it is in liquid state, or whether it is in gaseous state. So lithosphere is in which state? Solid. Astrosphere is in which state? It is in plastics. Okay. Astrosphere is in which state? It is in plastic state. Clear? So those classification you remember it, and then we discussed you have discontinuity also. What is discontinuity? The change that is occurring from when you are moving from crust towards mantle or from mantle towards core. Clear? Any doubt? So start with mantle in detail in tomorrow's class. Thank you. Anybody having any doubt?
No.